Welcome back. I have two examples for you in this short video, so let's get started. The first one is 4x minus 3 is greater than 2x plus 7. So as I mentioned in the previous video, you can do the same manipulations with inequalities. The only thing you have to watch out for is when you divide or multiply by a negative. So for this one, and keep in mind, it's not the only way to do it. So there's so many different ways that you could solve this problem. So I'm going to subtract negative 2x because my goal is to find out what x values are to make this inequality true. So I'm going to take everything to one side. So I'm left with 2x minus 3 is greater than 7. And then I'll add 3 so that it cancels out here. So I get 2x is greater than 10. Finally, I divide by 2. So since I'm dividing by a positive, I don't have to worry about the sign changes. So x is greater than 5. So what this means is that when I plug in things that are greater than 5, this entire inequality is true. And you can represent this multiple ways. So we know that we can use interval notation. So 5 and above, meaning 5 to infinity. And I use a parentheses here because it's not including. And I could graph it. So if this is 5, I can say everything greater than 5. So I'm going this way and beyond. Right? So that arrow just means it keeps going that way. And that's the first example. So before we move on to the second example, I want to demonstrate something. So 2 is greater than, let's say, negative 4, right? Which is true. Let's check what happens when we multiply by a negative. So let's just multiply by a negative 2 on both sides. So negative 2 times 2 is negative 4. Negative 4 times negative 2 is positive 8. So now, before we started, we had 2 is greater than negative 4. But once you multiply by a negative, the sign change happens, right? So whatever was positive is negative. Whatever was negative now becomes positive. And so that's why you have to switch the sign when you multiply or divide by a negative value, because it's going to change the direction. And with that, let's do one more question. So 3x minus 1 is greater than or equal to 6x plus 5. So I could just subtract 3x, but to demonstrate this principle that we just talked about dividing by a negative or multiplying by a negative, instead I'm going to subtract out 6x. So whichever way is correct, you could subtract out 3x from both sides or subtract 6x from both sides. So I get negative 3x minus 1 is greater than or equal to 5. And then I'm going to add 1 to both sides so that I can isolate my x. So I have negative 3x is greater than or equal to 6. And my final operation is to divide by a negative 3. But when I divide by a negative number, I have to switch the sign. So I'm going to switch that around. And it's 6 divided by negative 3, and over here I'm just going to have x because negative 3 divided by negative 3 is 1, and 1 times x is just x. So I get x is less than or equal to 6 divided by negative 3 is negative 2, and so that's my result. Once again, to show this in interval notation, it'll be negative infinity to negative 2, and it's including 2, so I'll have brackets there, right? Because x is less than or equal to negative 2. Or if I asked you to graph it at negative 2, you would have a bracket, and it would face the other direction because it has to be smaller. Okay, so that's it for our first set of examples. And we'll come back to some more examples that are a bit complicated.